Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle. And it's called Cookie Crime Part 1, Hide and Seek by Sandra and Nala. And I've done actually Cookie Crimes Part 2 and 3 before I did Part 1 because just the way that it worked with how I find these puzzles. And um but this is the first part of the Cookie Crime and let's see what happens. Here are the rules. We have the bag of treats is empty, and Nala has put on her guilty face. The bag had way too many of her chicken flavored bones left for her to have eaten them all, so chances are that she left some for later. But where? There seem to be some clues that might be useful for recreating Nala's creative backyard mapping and narrowing down the regions where she might have attempted to hide things. It's worth a try. Here are the actual rules. We have dynamic fog of war. The grid is partially covered in fog. Placing correct digits might clear some fog from its surrounding cells, possibly revealing more clues. Sometimes extra cells can be revealed as well. So this is not typical fog of war. It could, if you place a correct digit, it may or may not clear digits in the grid. That's just all it is. We have chaos construction, where every row or each row, column, and region contains the digits 1 through 9 exactly once each. A region is an orthogonally connected collection of cells. The shape and position of the regions have to be determined with the help of the following clues. So, what is an orthogonally connected region? It's basically just a region where you can go from any cell in the region to any other cell in the region just by going through edges, all while staying within the region. So this is an example of a valid orthogonally connected region, because to get from any cell in the region to any other cell in the region, you can just go through edges while staying within the region. This is an example of one that does not work, though, because even though these two cells can get to each other by going through edges while staying within the region, to get to the other cells in the region, they have to go through a corner, or they can go through edges, but they have to go outside of the region, which is not allowed. And that's an example of how orthogonally connected regions work. Now, to determine these orthogonally connected regions, what do we have? We have circles. There are 9 blue circles with thicker outlines in the grid. So these are the circles. Each blue circle belongs to a different region. And additionally, there are black circles with thinner outlines. So there are 9 blue circles with a thicker outline, and there are black circles with thinner outlines. So the 9 blue circles, each blue circle belongs to a different region. So this must be a different region than this, which must be a different region than this, which must be a different region than this. Additionally, and there are black circles. The black circles can be in any region, and a region can have more than one black circle. So a digit in a circle, blue as well as black, counts the number of cells that the circle sees from its own region in the row and column up to the first border, including itself. So say this region was like this. Say it was like this. This cell would then have to be a 6 because it sees itself and it sees all of these cells and this cell in its region. Right. And that's an example of how these circles work. And that works for both blue and black. They count the number of cells that are seen from its own region in the row and column up to the first border, including itself, right? So this would be a different region, so therefore be a border. In addition, you could have something like, say, this, right? Now, this circle would basically see 3 cells because it does not see past the borders. So it's blocked here, and then it just sees these 3 cells. So in this example, this would have to be a 3 if that's a digit in the circle. And that's how circles work. Small magenta arrows count the number of region borders seen in the direction of the small arrow. If a cell has more than one arrow, I think it's supposed to be, they see the same amount of borders in all pointed directions, not the sum of borders. And the outer edges of the grids do not count as borders. So, say we had a region here, and then a region here, and then a region here. This was a different region. So this would count border 1 here, border 2, so this was like, say, pink. This would count 1 border here, 2, 3 borders here. So this, in this case, this would have to be 3, and it would have to count 3 borders in this direction also, because there are multiple arrows, one pointing to the right and one pointing down. And so the number of borders it sees in both directions must be the same, and you don't count the sum of the borders that they see. And that's how these small magenta arrows work. And finally, we have digits separated by a white dot are consecutive, and digits separated by a black dot are in a 1:2 ratio. Not all possible dots are given, and there is no negative constraint in other words. So, for example, if this were, say, a 6, this would have to be 5 or 7 to be consecutive because there's a white dot between them. And let's make an assumption that this has a black dot here. Then if this were 2, this would have to be 1 or 4 to maintain the 1:2 ratio between them, if there was a black dot between those cells, and then this was 2. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these circles are all in separate regions. Let's first draw the boundary around the grid. But we know these are separate regions here, because each region has one single blue circle in them. Or each blue circle belongs to a different region, another way of putting it. So this we're going to make light, this will make medium, and this will make dark here. Well, light, that means since this has to go down here, light has to go here. That means light has to go this way, because this is a separate region from this, because, again, each circle is in a different region. So this must be light here, this must be a separate region, and is green. Or we're going to make it green. Medium has to go out this way, and dark has to go out that way. Because otherwise it doesn't make any sense. So this cell sees 3 cells in its own region, and that's it. So this would be a 3. This digit is in a 1:2 ratio with 2 other digits. 2 unique digits, I should say. And the only digit that can be in a 1:2 ratio with 2 unique digits is 2 and 4. So this is 2 or 4 with 1, 2, 4, 8 there, 1, 2, 4, 8 there. This sees only 2 cells because it sees these 2 cells and that's it. So then this is 2, which makes this 4. You cannot have a 2 in the region that has a 2, so this 4 is only in a 1:2 ratio with 2 and 8, so this is 8, and this must be 2 there. This sees 2 boundaries this way and 2 boundaries this way. Well, okay, so then, actually let's make this, we're gonna make this coloring green. We're going to make this red. And we're going to make this light and then this medium. Just some recoloring here. Because this only sees two boundaries here, we must see all green and then we must see red. Because of that, this has to be the same region because you can only see green and red here, right? If you don't see red here, the problem is red has to go out here somewhere. So that means green is all these cells, guaranteed, because you can only have 9 cells at most for red, and that means 3 only in column 2 at most. So this could be red or this could be green. We don't know. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have guaranteed 7 here. This is red. This cannot see this way because it would be too many. It's green guaranteed. And it sees all 6 digits here because if it didn't, that means another region would have to get through here, but then this would see more than 2 boundaries. So this has to be 6, which makes this 5 or 7, which is next to 4, 6, or 8. Cannot be 4 because of 4 in the column, so that's 6 or 8. These digits are in a 1 to 2 ratio. This can't see just 2 cells, can't see just 3 cells, so it has to see at least these cells here. These digits are consecutive. There's no 2, 3. There's no 6. So it could be 4, 5, 7, 8, or 9. 8, 9. Those are the possibilities. To be consecutive. This sees 2 borders. So there's another region that's going to be here. So this is dark. And this sees 4 cells, 5 cells, or 6 cells. Because it's going to be 4 cells here, at least. It can't be 1, because we need at least 2 digits to be orthogonally connected. And then this could be medium or dark. We're not sure which. Okay, this is in a 1 to 2 ratio. It could be 1, 2, 4, or 3 and 6 if this is 3 and that's 6. Okay. This red needs access to a 2, so it necessarily has to have a digit in column 3 at least, which means this cannot be all of the red cells, which means that's guaranteed to be green. It could be 6, 7, 8, 9. So red can go 1, 2. Red can go 1, 2. Red can go 1, 2. Wait, that's not possible. 6, 7, 8, 9. So this can't go that way. So it has to be either 1, 2, 3. Or 1, 2, or 1, 2, 3. We're not sure. What else do we have? This sees 2 boundaries here. This sees 2 boundaries there. Oh, black cells circles see boundaries. So this sees 8, which means it sees all of the medium or the light cells here. All the remaining light cells. This sees, it cannot see 8 because that's too few cells in There's 2 few cells in that region for it to see. So this must be 6 and this must be 5 or 7. This sees 8. So it sees 1, 2, 3, 4, 5, 6. At least these 8 here. But the thing is, if it goes 8 here, the problem is this can't form a region. So it can only be 7 at most this way. 1, 2, 3, 4, 5, 6, 7 cells seen, so it must go that way. So this is definitely a border. This cannot be 2 or 4. So this is 1 or 6, which is in a 1 to 2 ratio with 2 or 3. This must be see the same borders here as it does here. Right now, that's 1. You could have 2 or 3 at most this way. So this is also a 2-3 pair. Right, so this could see 1 border here, 2, 3 at most. And then this would see the same amount this way. Okay, these digits are, this sees 6 cells. So the green has to go either 6 that way, or you could have 6 that way. We don't know. Either way, we know that this sees 6 cells. 1, 2, 3, 4, 5, 6. And these are guaranteed, or 1, 2, 3, 4, 5, 6. So we know these are going to be boundaries. But we don't know about this. This sees 8. It could be... This sees 1, 2, 3, 4, 5, 6, 7. It could see all of those. So light could see all of those. This can't see 7 this way. That's going to be problematic. So if it tries to see light going... Oh, it cannot go here. Because this sees 2 or 3, right? So then this sees 1, 2, 3, 4... 5, 6, 7, 8. And then medium can get out and dark can get out. Otherwise, if it's less than that, it's too many. Right? It would block in medium and then dark could get out, but this medium would be 6 cells because this must see 2 boundaries this way. So this must go here, and this cannot have both 2 and 3 here. So this must be border here. This is 1, 2, 3, 4, 5, 6, 7, 8. So this is the region there. Then medium. Ooh, we have a problem. This sees 6 cells, but this must be 6 and 3 because you can't have a 2 here. That's... Huh. That's problematic. This sees 2. This sees 3. So that's in a 1 to 2 ratio with 6. How does that work? Oh, this could be 1. That's how you could do it, because otherwise this is going to break. So this has to be 3, because we know that's 6. This could see 1, right? I totally forgot about that. And this is not green, therefore it's light. This sees 1 boundary that way, it sees 1 boundary that way. This then is boundary here. This cannot be red, it must be green. So then this goes boundary that way. So this must continue down because we have to have a red here, guaranteed. So therefore this must be down here as light. This cannot be 6. So therefore this can't be medium here. It's definitely dark. This is a boundary here. So we have 1, 2, 3, 4, 5, 6, 7, 8. And then this could be light or this could be light. We don't know. And then we have red being one of these two. So we need a 4 somewhere in this green region. 1, 2, 3, 4, 5, 6, 7, 8, 9. Can only be here. So that means this cannot be a 4, 5 pair. It's 8 with 7 or 9. These digits are consecutive. There can't be 1, 2, 3, 4, or 6 because 1 requires 2 to be consecutive with it. Can't be 5 or 7 with the 6. So we're guaranteed 8 is here. And it must be with 7 or 9. So 8's guaranteed to be here. 8's guaranteed to be here. We need 2 and 4 in the red region. It cannot be here or here. So this must, one of these is 2 or 4. So that means the remaining digits in this red region are 1, 3, 5, 7, 9. Because we already have 8 here. And the 2 or 4 has to be here. These are light. They cannot be... It has to be 5, 7, or 9. And this is either 2, 4, or it's 5, 7, 9. We're not sure which. This is definitely 2 or 4 here. Remaining digits in column in the green region. Well, we don't have a 3. So where's 3 can't be here. 3 has to be here. So this is 3. That sees only 3 cells, so it cannot see that cell in the region. So that must not be light, it's red. So this must be a 2, 4 pair here. Because this cell only sees 3 cells. So this is done as a region. That means this is 2, 4 as a pair, which eliminates 2 and 4 in the rest of the column. This can't be 4, it must be 5. There's no 5 here, no 5 here. This sees 5 cells, so this cannot be dark. It's medium, therefore that's a border there. It sees 2 borders there. This sees 1 border. This is a separate region, and so this must be light here. So that's done as a region here. This must be pink. This has to be 5 remaining. So this is 5. These must not be 5. Because that would... They see already 5 cells in the region. So therefore this must be medium and this must be medium. Because you have to see 2 of these at least. And then one of these sees more. And they're consecutive. So right now, we have 7 cells in the region. That means you can see up to 2 more. Which could be 8. So you can have 6, 7, or 8 here, and 6, 7, or 8 there. We're guaranteed, though, one of these is 7. This can't be 7 because of it's next to a black crop key dot, which means this is 7 here. This sees 7 cells, so it must be those 3. This can no longer see 8 then, because we have 1, 2, 3, 4, 5, 6, 7, 8 cells. So this must see 6 cells. And this must be 3. That means this is the most that it can see here. This is the most it can see there. So we are guaranteed it has to be one of these two to fill it out. So this has to be the last remaining digit of the medium gray region. This sees 3 boundaries that way. Okay, remaining digits of the medium region. Well, first of all, we need a 2. 2 can't be here or here, so 2 has to be here. How many boundaries does this see? It sees 1, 2, 3, 4 at least, so it must see a 5th one. So then this must be a boundary here. I think we're going to make this one yellow and this one pink. So it must see 1, 2, 3, 4, 5 boundaries because we already have a 4 in the row. So this is 5. This is boundary here. Yellow has to go down. Pink has to go down, which means yellow must go down a further one. This sees at least 3, and it could see up to 7. So this is 3 or 7. So it either sees 3 here, and then it goes that way. Remaining digits of the medium gray region. We have 4 and 8 cannot be here, so this must be a 4-8 pair, which leaves 1 and 9 remaining in row 1. That leaves 1 and 9 remaining in the medium region. That leaves 6 and 7 remaining in row 2. Remaining in the green region, we have 1, 5, 7, 9. Okay, we have a 7, 8, 9 triplet in row 6, which eliminates 7, 8, and 9 in the rest of the row. So this is 1 through 6. This cannot be 5 here. A digit in a circle can never be 1, because remember, all these regions are orthogonally connected, so it must always be at least 2. These digits are consecutive. This cannot be 5 here. You can't have 3 or 6 here. This can't be 2 because of 2 in the region or in the row. This can't be 5 because of 5 in the row. Remaining digits in row 3 are 1, 3, 7, 8, and 9. No 3 here because of 3 in the column. This is 1, 3, 7, 8, and 9. So this digit is in a 1 to 2 ratio. It cannot be 4 and 8 because that would eliminate all possibilities for that cell there. 1 could be with 2 here, 2 could be with 1 or 4, 3 can be with 6, and 4 can only be with 2, 6 could be with 3 there. These digits are consecutive. The only digits consecutive with 7, 8, and 9 would be 6 through 9, so 1 and 5 can't be here, therefore this is 7, 9. And that's consecutive with 8. So this is 8. This cannot be 8 here. Where is 8 remaining in row 6? It must be here. So this is 8, which means this can't be 8 here. It's 7 or 9. This 7, 9 pair eliminates 7, 9 in the rest of the column. So this is 7, 1 or 5 here. Remaining digits in row 7, again, are 1 through 6. There's no 5 here, no 2 here, no 3, 6 there. This sees either 1 boundary or 2. We're not sure which. This sees 5 boundaries. This sees 2 boundaries. This sees 3. Okay. This sees 5 cells, and it cannot see past this circle because then you would have 2 blue circles in a region, which is not allowed. So this must see this way and that way, and it's part of this region then. So this sees that way, it's dark, it's part of that region because these cells can only be part of that region. That eliminates 1, 9, and 6, 7 in the rest of the region. This can't be 1, it's 2. So that sees 2 boundaries. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's done as a region. That leaves this digit as a 4. So this is 4, which makes this 8, which makes this 4. So this cannot be 4 here. This can't be 2 or 4 here. It sees 3 or 6 cells. This must have 2 boundaries. So we're going to make this one orange and this one blue, and they both have to go out. So this is orange, this is blue there. That sees 2 boundaries. This is blue that way, so it can't. This is going to be a boundary here. So then we have, this has to go that way. If we have orange going here, pink has to be part of this region here. Well, can you get 5, 6, 7, 8, 9? You can't reach there without going this way. And that would force this orange region to be too small. So orange cannot go this way. Orange then has to go this way. This is pink. So we have boundary here. That means all of these are going to be pink because there's no other border you can reach. Like, there's nothing else that can get in here without pink being blocked by a region. So this is pink that way. No 2 or 4 here. Remaining digits of column 7 are 1, 3, 6, 7, 9. No 3 here because of 3 in the row. This sees at least 5 cells, so it's 5 or 6. Since this is 5 or 6, this cannot be 5 and 6. So there's no 5, no 5 here because this can't be 6. This can't be 4 or 5. So if this is 1, 2, or 3, this can't be 3 there, it would be 6 there. This cannot see 6 cells because we already have 4 cells that it cannot see in its region, so this must be 3. So this is 3, which means this can't be 3. That means this can't be 4 here. This is a 1-2 pair, which is in a 1-to-2 ratio with 1 and 2. That eliminates 1, 2, and 3 here. No 1, 2, or 3 here. This is 4, 5, or 6. 1 and 2 is in a 1-to-2 ratio with 1, 2, or 4, not 5. 1, 2, and 4 can be consecutive with 1, 2, 5, because 3 and 6 are already in the column. This cannot be 1 and 2, though, because that would eliminate all possibilities for that cell there. So this can't be 1 here. We are guaranteed this has to have a 2 here to be in a 1-to-2 ratio. That means these can't be 2. These cannot be 2. This sees at least 4 cells. It must see another one because it must be orthogonally connected. So this is also 5 or 6 here. This can't be 3 because of 3 in the column. Okay, so this sees 1, 2, 3, 4, 5, 6. It sees one more here. Remaining digits of... Okay, we know 2 is one of those. This cannot be 2 and 2. So this must be 4 and 5 to be consecutive. So we have 4 and 5, which is in a 1-to-2 ratio with 2, which is a 1-to-2 ratio with 1, which makes that a 2. Okay, so this cannot be 4. This can't be 4. This is 1 here. Remaining digits in column 4 are 3, 6, 7, 8, 9. 3, 6, 7, 8, 9. 3, 6, 7, 8, 9. No 3 here because of 3 in the row. No 3 or 6 here because of 3 or 6 in the row. This can't be 6. So 6 is one of these 2. Can this ever be non-yellow? So if we have yellow going here, the problem is this can't reach any other region. So this has to be all yellow this way. So then this must be 7. So we have this 3-8 pair eliminates 3, 8 there. So this is why that's 7. So then this becomes a 1-9 pair here. No 7 in the remaining digits. This is all yellow here. Yellow has to be one of these digits here. So we have 1 and 2. We have 3, 6, 8, and 9. We need access to a 4 and a 5. So one of these 2 is going to be yellow. This can't be yellow. So I think it has to be part of pink, right? And this sees only 3 boundaries. So it can't be yellow here and well, you can't. You need 4 and 5 in the yellow region. So it can be 2 yellows here, or it could be 4 and 5, or 5 and 4, whichever way. Remaining digits of column 5. we have 1, 7, 8, and 9. And this can't be 1. So 7, 8, and 9 are already in the yellow region. This can't be yellow. So it could be pink. I don't think it could be orange, right? 1, 2, 3, 4, 5, 6, 7, 8, 9 would be orange, but then this would be 6 as a pink region, which is not possible. How about this one? 1, 2, 3, 4. So we need at least 2 more in the pink region. If this is not pink, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's not possible to be pink either, or orange either. So this is guaranteed to be pink because it cannot be yellow. So this is 1, 2, 3, 4, 5, 6, 7, 8 pinks, and this sees 3 cells in the region. So this cannot be pink here, it must be pink here. So then this is full pink. This cannot be yellow, so this is a boundary. And this must then be yellow here. Or blue can never reach here. 1, 2, 3, 4, 5. This has to be blue because there's no other region it could be part of. And again, this is 1, 6, 7, 8, 9 at best, so this can't be blue. It must be orange, which means it has to exit out orange here. This must be orange, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's done as a region, which means blue is the rest of the region. So this is blue. This sees 6. This sees 5. So this can't be 5 or 6, it's 4. No 4 or 6 here, it's 5. No 5 here, no 3 here. This is 1, 6 as a pair, which eliminates 1 and 6 in the rest of the row. So this is 3. So this sees 3 cells, this sees 3 boundaries, this sees 2 boundaries, this sees 2 boundaries. And the rest is just irregular region Sudoku. Okay. Pink region needs 1, 4, 6, 7, 8, 9. This can't be 1, 4, or 6. So we have a 1, 7, 8, 9 quadruplet in the pink region, which eliminates 1, 7, 8, 9 in the rest of the pink region. This can't be 1, it's 6, which makes this 1. This can't be 1, 6, 7, 8, 9, so it's 4. So 1 eliminates 1 in the rest of the orange region. It also eliminates 1 in the column here. So this is 9, that's 1. This can't be 7 because of 7 in the column here. This can't be 9 here. No 1 or 9 here. It's 6 and 7. 6 already has... Blue has a 6. Also, this 6 eliminates 6 here, so it's 7 and 6. This can't be 6. It's 7, which makes that 6. No 1 or 7 here. These digits are consecutive. Cannot have 3, 6, or 7. So this could be 1, 2. It could be 4, 5, or it could be 8, 9. Well, this can't be 4, 5 here because of 4, 5 in the column. So this can't be 4, 5. Can't be 8, 9 here because that would eliminate all possibilities for that cell there. So this must be 1, 2 as a pair, which eliminates 1 and 2 in the rest of the row. This can't be 2, it's 4, which makes that 2. 1 eliminates 1 here, so it's 5, which makes that 1. Therefore, this can't be 1 anymore. Where's 1 in the green region? It must be here. So this is 1, which makes this 9, which makes that 8. 7, that's 1. 9 eliminates 9 here, so it's 8, which means this can't be 8 here. This can't be 6 here because of 6 in the row. So where is the 6 in the yellow region? It must be there, which leaves that as a 9. Remaining digit in column 6 is a 3. That leaves 2 and 7 here. This can't be 2 because of 2 in the row. So that's 7. This is 2, which makes this 1 and that 2. 7 eliminates 7 here, so it's 5, which means this can't be 5. 3 eliminates 3 here. Where's the 3 in column 4? It must be here. 7 eliminates 7 here, so it's 9, which makes this 7. which makes this 9, which makes that 7, which makes that 9, which makes that 7. Okay. 1 eliminates 1 here, so it's 9 and 1. 3 eliminates 3 here, so it's 8 and 3. Remaining digits of row 4 is 8 and 9. This can't be 8 because of 8 in the column, so that's 9, 8, which makes this 9. Remaining digit of row 5 is a 5. Remaining digit of column 9 is a 4, and that leaves that as an 8. The solution is correct. Nala was shocked when she found that one of her 2 cookie hiding spots had been plundered. She ran to the other one, and to her relief, it was still untouched. It was not plundered by her. At least she couldn't remember doing it. So who and where is the cookie thief? And that leads to the cookie crime part 2, which I have already done. I will post a link to that puzzle in the corner. And yeah, this wasn't too bad. I did make this mistake here, but I soon realized it had to go this way because otherwise this was problematic. Could not go 6 that way. And so then I realized this had to be 1 instead of the 2 that I hadn't made that assumption. Anyways, I hope you enjoyed that solve, and I'll see you next time on Frank Puzzles. Take care.